Hi, this is Gary Audin. I'm at the Internet of Things Summit in Washington, D.C. And with me today is Gary Butler, Chairman and CEO of a company called Camgian, one you probably don't know much about, but is right in the middle of implementing and providing IoT products and services. We'll start off, first of all, with a general question. What is IoT? Because I've heard several definitions of it here today.
I think the way we look at IoT is really the marriage of the physical world with the world of computing. So if you think about how the Internet's evolved today from terminal mainframe to client server to mostly mobile, moving from thousands to millions to billions of devices, the Internet of Things will be this fourth generation of the growth of the Internet into the connection of physical assets. So it's moving beyond the connection of people into the connection of physical systems such as equipment, infrastructure, and buildings. The benefit of that obviously is that if we can generate data from those assets or those things, if you will, and we can process that using a very advanced software, we can drive revolutionary improvements in operational effectiveness and efficiency in various business industries.
Well, let's go to some industries. At the conference here, they've mentioned several different vertical markets. What are the ones you're seeing?
Well, we're primarily focused now in three vertical markets, one being smart retail, smart infrastructure, so that's moving Egbert devices, for example, out into physical infrastructure such as bridges, dams, locks, levees, and also smart cities where we're deploying systems to monitor things like pollution, foot traffic, environmental, local environmental phenomena, as well as vehicle traffic.
When you produce something for this kind of market, are you having problems getting people to imagine what to do with it?
It's a good question. I think it was a question that came up several times over the course of the conference over the last couple of days. Of course, we're in an early stage of adoption of IoT technologies, and many of the clients we work with, in fact, have never heard of IoT. We tend to sell directly to an end customer, and what's really important in terms of adoption is delivering a strong return on investment, putting together a very solid value proposition and demonstrating that value proposition, whether it be in an early pilot with those clients. But I think once that value proposition and that return on investment is solid, I think then it becomes a question of economics, not technology at that stage.
Most of what IoT is about sensing things, measuring things. Where do you fit into that environment?
It's a good question. So if you look at how many of the IoT solutions, especially on the enterprise side, are built today, they're built by integrating legacy products such as sensors, gateways, routers, communications, and analytics into solutions. Now, the problem is that those solutions are very expensive to build. They have long lead times to market. In many cases, they're not scalable and unsecure. So we fit in by developing an end-to-end platform comprising hardware, software, communications, and networking that provides a seamless user experience and addresses many of the issues that I mentioned before. So our system is fully integrated. We can move it into the market in a very quick and rapid fashion, and we can deliver value to a client in a very quick way.
On the panel I listened to that you're a member of, one of the questions was centralized versus distributed architecture. What is your architecture like, and why did you choose that?
Sure. So a centralized computing architecture is simply the design that supports the streaming of sensor data back to a centralized location where analytical processing takes place. So many of the solutions that are out there today in the IoT market really are built around this type of architectural platform. Our system is what we call an edge computing platform, so we push the real-time processing of the sensor information out to the edge of the network, and we reserve the software applications running in the cloud for higher level processing and tasks. There are a lot of advantages to that in terms of the markets that we're focused on and the customers we work with. For example, we can reduce what's called the data footprint associated with operating these types of networks, which are directly associated with the cost of communications, the cost of back-end storage and processing. By moving that initial layer of processing right out to the edge of the network, we can take the burden off the communications. We don't communicate as much. We don't store as much information in the cloud, therefore saving cost and reducing long-term cost of ownership of these systems. Now, there's a secondary benefit of running edge computing, especially, again, as it relates to some of the markets that we're focused on now, and that is we can reduce the amount of communications time, which is a very power-hungry activity with the device. So if we put more burden on the processing, we can save power. We can reduce the overall power consumption of the system and run the system for many days out to many years if necessary. So it allows us to expand IoT networks into vertical markets such as agriculture, smart infrastructure, smart cities where AC power is not available. So it really starts to play towards the entire theme of connecting the physical world, which in many cases is not constrained by the AC power grid.
That leads into the demonstration you just showed me of a box called Eggware.
Edgeware.
Edgeware.
Yes,
okay.
Edgeware. Edgeware, as we define it, and the reason we put that in the briefing today was we wanted to drive home a point, and that was that what you see there is a combination of very advanced hardware and software optimized to work together. It's not a piece of hardware, really, and I think Edgeware, which I define as the combination of very advanced hardware and software operating at the network's edge. And I think Edgeware is going to be a very important technology going forward in IoT, because if you look at, from an architectural perspective, if you look at the complexities associated with building IoT architectures and networks, a lot of those complexities exist at the network's edge. So if you think about the billions of diverse physical systems that we have to connect networks to, that network connection is not straightforward. If I'm putting devices on a pump, or if I'm putting devices in a vehicle, or if I'm putting devices on a pipeline, all of those interfaces are different. With traditional networking today, those interfaces are well defined, but IoT is more ambiguous in that regard. So building what we call effective edgeware that can connect to sensors. Sensors actually operate, if you will, as the voice of that asset. So if you take an asset in the field, again, a piece of equipment, sensors provide some information about that asset, and then we process that information. But again, that's where the software comes in. It has to have advanced software running right at the edge of the network to make this entire architecture work. So again, it's not just a piece of hardware, it's a combination of both. And they have to be designed to work together. They can't be designed in a silo.
That Edgeware box, though, I can imagine is going to be installed in a lot of different conditions. Is it sort of sensitive, or is it relatively robust?
It has been designed to work both indoor and outdoor. So we have two different enclosures. The enclosure that you saw today was the indoor enclosure that we have, but we also have made provisions for outdoor enclosures that meet all of the environmental standards for industrial operations as well. So all of that has been integrated into the design of the system.
One of the points made at this conference, and the term kept coming up, power management. How have you dealt with the issue of that this is going to be a box that's going to be out there possibly for years, and there aren't going to be technical people on site to deal with it?
Great question. So the first way of skinning or addressing that problem is ensuring that the endurance of the system as it runs on batteries can meet the requirements of the customer. So I'm going to talk a lot today about what we call TCO, total cost of ownership. And so deploying solutions that require AC power, especially when AC power is not available, is a very expensive proposition. So the system has to run at very low power to enable it to run on batteries for a year, 2 years, 3 years, many of these applications, to keep the TCO low enough. Because if clients have to go out and service batteries every month or 2 months or 6 months, all of a sudden it becomes an expensive proposition to adopt. Second component of this is what we call cloud management, and everything on that device is managed from the cloud, from its operations and control to the way it's configured, and also any future upgrades of firmware is done over the air. So we design that feature into the system to reduce the amount of on-site technical support needed for these systems. So basically, once a system is put in the field, we can control it completely from the cloud and over the wireless networks. And again, running at low power, these systems don't require maintenance but once every few years at that stage.
It seems that what you're going to be measuring and people are making decisions on really deals with the operation of an organization. How does IT fit into this, or does it not fit into this model that you're offering?
Great question. We've seen a combination of both. In some cases, given the fact that this is driving operational intelligence to help customers make better decisions about how to perform their day-to-day business, sometimes that circumvents IT and sometimes it doesn't. We've had occasions where we've worked directly within clients, we've gone straight to the operations personnel, and we've had other cases where we've worked with clients and IT was involved. So I think what we're going to see in the IoT market in general is that you may have a combination of both, but in the case of our system, ultimately this network runs completely independently of their internal networks in the company, which may obviate the need for working with IT and having their involvement in the operation of the system.
So essentially it's independent of IT, and that they may not even know it exists.
Yes, true. Yeah. Hopefully there are the communication channels within the company to ensure that that doesn't happen, but that's a very likely possibility.
Now, you showed an example of a retail operation of measuring several things in real time with alerts and the like. What kind of decisions can the company do, let's say in retail, make through the information you provide?
Well, I think those decisions would actually break down into two categories. I think the first category are real-time decisions, meaning that, for example, we showed a situation where an alert was created about a cooler that had basically stopped functioning. In the retail sector, obviously, that's important because they need to know when that happens so they can move merchandise from one cooler to the other and save thousands of dollars of product. So you have these real-time alerts and real-time actions that have to take place within a store, for example. Security would be another example of that. Then I think you have longer, more strategic decisions that are made. So, for example, as it relates to retail, things like foot traffic where people are moving in the stores, those are strategic decisions as to how the stores need to be laid out, how advertising needs to be conducted, what's the effectiveness of advertising. So again, I think with our system, you really have a flavor of both types of actionable intel. One is near-time action, one is more strategic.
The near-time action seems to be really easy for people to grasp, but the long-term, do your clients sort of have to learn what this information actually means and relate it to other elements within their organization?
It's a great point. I think as we pointed out today, the value proposition is fairly clear when it comes to these near-term actions that need to be done. Again, I've got a piece of equipment that's gone down. I have to fix it. There's cost associated with its downtime. The value proposition is very clear in those cases. It's a little more ambiguous when it comes to the more strategic side of the information, which probably is equivalent to the kind of information one would have in a BI type platform. But I think our customers see both sides of it. As it relates to foot traffic, and when you correlate foot traffic with more traditional business intelligence information like sales, for example, then one starts to glean some very interesting correlations there in terms of how their store is actually operating. And but again, those are more strategic and a little more difficult to quantify until those operational changes have been made and the results of those changes have been quantified.
I noticed in some of your graphs where we're dealing with income per customer, number of customers in a time period, it would seem that the information you provide actually stimulates new questions to answer for a lot of the clients. Agreed.
And I think these are some metrics that they've really never had insights into before, which I think sometimes precipitate more questions, adding more sensors, collecting more information. So yes, I think you're right. It's a multi-layer, multi-dimensional problem when you start digging into the operational scenarios of these systems.
Well, thank you very much. Is there anything else you'd like to add before we're done?
I don't think so. Thank you.